Greetings, Wazers, and welcome to another very exciting episode of Waze Community Office Hours. I'm your host, Brett, and with me today is Philippe Adjiman from the Waze Data Guild. We were originally going to have Roy Sasson, our head of data science, but unfortunately he couldn't make it. However, we are in very good hands with Philippe today. He's going to take us through all the different ways that data improves Waze. But first, one quick announcement. Make sure if you are a beta community member that you take the beta community survey. It's the best way for you to tell us how we're doing and what we can do to better support you all in all of your endeavors to help us make the Waze app the best it possibly can be. Danit just posted the survey link right in chat. And with that, I'm gonna pass things over to Philippe so that we can dive right in. Philippe, why don't you take it away?
Thank you, Brett. So hi, everyone. I'm very happy to be here. My name is Philippe, and I'm here on behalf of Dr. Sasson, who couldn't make it today. And I hope we have a great session together talking about data at Waze. So we'll start by presenting our team. This is the Data Guild at Waze. And we are about 40 data scientists and data engineers all together. And we are responsible for about 200 data pipelines and even more tables that we are handling and managing every day. And here you can see Roy Sasson, the head of Data Guild. And because that day on the offsite in Greece, I couldn't stay there and I had to go early at home, you can see me around here on my flight back to home. So in every data science team, what you will hear about is that without data, you're just another person with an opinion. This is something we'll hear all about, right, all around. But in our Data Guild, we like to add a new part of this sentence, is that without an opinion, you're just another person with data. And what we mean by that is that very often it is critical to have the opinion of the users and specifically your opinion of the editors to make our features even better and to strive with our data. And this is what we will talk about today. We will give a couple of examples of those, of where like the editor input is critical to make our feature even better on the data side of things.
Sorry, I forgot to mention, if you have any questions, we're going to be taking questions live. Danny, can you drop the link for the Q&A in the chat? Amazing. Thank you so much.
Okay, so let's get going. So the first example we talk about is how the community helped us improve ETAs in complex junctions. So before we get there, we will explain about our new latest model that is released in production actually since a bit like a year and a half ago, and it's called Smart Sum. And we will give you some intuition about how it works, but basically the input of this model is that we get a set of segments that we want for each of them to estimate what we call the cross time, how much time it will take to cross that segment. And when we have all the segments of the route, we sum them up together into a smart way, hence it is called Smart Sum. So just to give you an intuition of how it works, let's take an example. Let's say that I'm going from home to work in the morning at 7 a.m. And then I just need to make an estimation of how much time it will take from home to work at 7 a.m. So in my hand, I have a lot of signals together. So the first one is the traffic data. So for each of the segments, we know what is the typically time that it takes right now to go through that segment in real time, and also the historical time. So it is important to understand that when we build the ETA prediction at 7 a.m., the time that is in real time is more important for the first segment because this is what is happening right now, right? So at the end, the segment that will be there in 40 minutes, we need more like the historical time because we don't know exactly what will happen in 40 minutes. So we need to base this information on the historical time. And together we need to blend them into a smart way to estimate the ETA, what we call the estimated time of arrival. Now, another type of signal that we use is the spatial info. For instance, which type of segments are we talking about? Is it a segment? Is it a highway? Is it a small street in my neighbor? All this kind of information is also critical to estimate the time, the cross time for each segment. Then we also have temporal info. For instance, we know that we are in the morning at 7 a.m., that this is the typical commute time, and that in 40 minutes, we know that there will be a lot of traffic, so we need to take that into account. And also the personalized info. For instance, Waze knows that I'm driving like a grandpa, so we have to take that into account and to inject that into the information of the ETA estimation in a personalized way. So all those are kind of signals that are already used in production by the machine learning model. And we also have a lot of other signals that we plan to use in the future, like The public events, we also talk about public events in that presentation in a minute, and the navigation intent, how many people are actually trying to drive in such direction here and there. This is also a signal that we want to take into account in the future. And also Google Maps data is also obviously something that we want to take into account altogether. So this is basically how the SmartSum model is working. And now, as I'm sure you were all waiting for, we'll talk for half an hour about deep learning, neural networks, and model architecture. So yeah, just kidding. We'll just give you an intuition of how the model is looking like in general, like each segment we have as an input of the model. And as we said, we had a lot of signals for all of those segments. We call these feature vectors. And we use what we call a recurrent neural network. Without entering into the hardcore details, it's about impacting the beginning of the segments all over to the end of the segments, and to have an impact of all the segments in a consecutive manner, so we can understand what is the impact of the beginning of the drive to the end of the drive. And then we basically take all the information that is what we call contextual, where we have the information about the time and the segments, the physics of the road and everything, and we combine them all together to have an estimation that is combining the real-time and historical information with the contextual information. All those together are forming with all kind of the deep neural network layers. At the end, gives in green for each segment what we call the cross time. We have a cross time for each of the segments separately, and we just sum them together, and we get our ETA estimation, the SmartSum. So now, the great news is that this model that was released a year and a half ago brought great results. We saw a 20% reduction in bad ETA sessions thanks to this algorithm. And it is really amazing to see that. And the great part is that the algorithm is learning continuously. So it is flexible and capturing all the different traffic patterns that are changing over time. And this is something that is really important, because sometimes, there are big changes, like the great example in the past years was COVID, where a lot of traffic patterns changed altogether. And now this kind of model is able to capture over time, to retrain and to learn the traffic data over time, and to take that into account. Also, when we want to add like new signals, we'll be able to do it in a much more flexible way to inject them into the deep learning neural network that is called SmartSum. Now, there is that bubble that you probably all familiar with. It's a very annoying one. Like when you are in the middle of a traffic and Waze suddenly says, okay, it will take 7 minutes more. So those are very, very annoying. So I just want to ask a question for people like here in the chat. How much of those bubble you think we have in a year? I will give you three options: 1 million, 1 billion, 10 billion. So I give you 10 seconds to think about this, and let's see what are the suggestions we see in chat. What do you think, Brett?
I'd split the middle and go 10 million, maybe.
So it was 1 million, 1 billion.
No, 1 million, 1 billion, and 10
billion.
So let's say 1 billion. Then.
Okay. What's the guess on the chat? Let's see if we have any.
Still might take a couple of seconds to roll in.
Okay. So we'll give it a few more seconds, and otherwise we'll give the answer. Oh, wow, we get some answers. 1 billion for Mika. 10 billion, 1 billion.
Oh, here they come.
Okay.
Don't know, number 90% or 7. Everyone's agreeing with me on 1 billion, it looks like.
Wow, so I think we're in presence of a very smart audience, because that's the actual answer. It's 1 billion. Yes. Congrats, everyone. So the great news is that SmartSum is reducing those by 50%. What it means is that we are just left with 500 million a year.
Not so bad.
I mean, it's still a lot, but it's amazing considering that it's one model that changed that for like such a huge amount of annoying pop-up like this one. So half of them were just saved for our users, which is amazing. So back to the presentation.
Here, we gotta click up first. There you go.
Great. So what we see here is actually a very complex junction that is just at the bottom of the building we are currently sitting in right now. It's called the Ashalom junction, and it's a very, very complex one. And it happens to be also the junction that Roy Sasson, the head of the Data Guild, is driving every morning. So in a second, we'll see why it is actually a good thing. So here we'll talk in a minute about what are those X, Y, and Z, etc. But what Roy Sasson is sending when he's driving those junctions is this kind of emails. So usually those are one title emails where like Roy is sending a feedback saying, I got a bad ETS session today with some typos because he's driving, and he's managing to send his logs anyway. And it starts like that. And then a few days later, it starts to pile up with another feedback, like ETA in Ashalom today was too optimistic. And then again, the day after, you can see the anger building up by Roy saying, we really have a problem in this junction. We need to do something about it. I got another bad ETA session today. So from there, like what happens is really like our data scientists are looking in the data and try to understand what is happening. And what is showing up here is something very, very interesting. So because it's a very, very complex junction, it turns out that the segments are impacting it back like segments, not only the segment before, but two segments before. What does it mean? Like, for instance, you see here the segment Z1, which is a term on the right from Y, is not only impacting the cross time of Y, but also the cross time of X, which is two segments before. And it turns out that when you look at the actual data, you see that the cross time for X is very, very different if you are going to turn two segments after into Z1 versus if you continue straight to Z2, two segments after. So we call it like the next segment. And it's really interesting because look at the cross time. It's like 30 seconds on X if you are going to turn in two segments in Z1 versus 220 seconds if you are also on X, if you are going to turn on Z2 two segments after. So this is something that was very important to take into account, and we have to do something about it. So just to get a sense of how much it happens. So first, if we take the top junctions like those in per country, and we try to capture how much percentage of those are actually in terms of session, capturing the session of our users, we see that in Israel, it's more than 50%, Malaysia, 50%, Australia, 25%, and so on. And also what we observed is that on those junction boxes, the likelihood of getting a bad ETA experience is 5x more likely than in any other type of segment. So it's really a very concrete problem and a very important one to solve. So the approach that was taken is that in the first phase, the data scientist flagged about 300 of those candidate top junction boxes that are complex. And here, with the help of the community, with your help, we were able to narrow down to only the 20 most relevant ones. And it was really, really critical to focus on those 20 segments, like 20 junctions that are the most complex and important to solve. And thanks to you, we were able, and discussing with you and with Gil and with everyone, like one of the options that came up was to use the notion of junction boxes to actually bundle up together the two segments, like the X and the Y that we discussed before, and to do the estimation on this box, not on X and Y separately, but to do the estimation on X and Y together. And with that solution, we observed that the result was really, really, really good. We observed a great improvement in the estimation. And the phase 2 of that was to actually expand to other countries than Israel. And with your help again, we were able to capture in different countries all the important junction boxes and junction that we wanted to improve. And it was really amazing. And the next phase that we will focus on is to make this production grade, to scale this automatically to any kind of junction boxes based on the type. And this is possible only from the learnings that we were able to have from your help here in the community when we are mapping all those junctions that are very complex ones. So that was the first example of where your help was critical into getting mature about how to handle a very, very complex situation without rewriting completely the model of SmartSum. So now we'll take a second example, one that is called MTE, the major traffic event. And our goal is to grow them, and we will explain why in a second. So here is an example of a major traffic event. It was some time ago, Manchester Marathon, and we can see here a lot of different closures, segments that are linked together into what we call the major traffic event, as you obviously know. And now the idea is that not necessarily everyone knows about the impact of mapping those segments into an MTE, because sometimes you just have the segments, right? But if we don't do the extra step of connecting them together into this major traffic event entity, then we miss some very, very important added value that our users are getting. So for instance, as soon as we have an MTE, a lot of good things are happening on the user side. First, we're able to send what we call the PDNs, the pre-drive notifications. Those notifications that we send the day before of the actual MTE to our users to warn them about the upcoming major traffic event. Also, at start of drive, we are showing those banners that says to the user that there is an MTE on their way, which is a very useful information that sometimes can explain why Waze is taking the users on some potentially unusual routes. It's because of a closure or an MTE, and here we can see it. So this is why it is really important to have those MTEs mapped actually, and not to have just the segment of the closures lying there without any connection. And what we observed in the data by doing A/B tests is that those kind of pushes are actually driving growth. Like we observe more drives per user per month thanks to those PDNs, which is really, really exciting and important. It tells a lot about how much those notifications are useful to users. And there is here hiding behind the scene a kind of virtuous feedback loop. Like we all know about the feedback loop, that the more our users are using Waze, the more we get data, the more our models are getting smarter. And here, exactly in the same spirit, we have also a very, very interesting feedback loop, which is the more we are able to send those notifications to our users, the more they will be using Waze, and the more we will be able to predict what are their future drives. Because those notifications can be sent only to those users we know will drive on this route where there will be closure. So there is a lot of machine learning and models behind the scenes that are estimating what is the chance that we will drive to that route tomorrow. We call that future drives. And the more we send those PDNs, the more users will be using Waze, and the more we'll be able to understand and infer those future drives. So it's another feedback loop, and that we want to have here, and it is critical. So now, if we look at the actual percentage of monthly active users that are enjoying those PDNs, we have here all the numbers. It's quite a lot. And we want to increase them even further because we know they are useful, and for now it's quite narrowed. Like depending on the country, sometimes it's a bit lower than what we would expect, and we want to do a lot of initiatives and efforts to increase those. And this is where you come into play, and you can help us a lot. So just before that, I will just remind the high-level numbers of pushes by month in some countries, and we see that there is a lot of seasonality. Like in January, you have much less pushes sent, and actually much less major traffic events. And we want to understand why sometimes it's a question of just the month is a lower month, or maybe sometimes we are less able to map a major traffic event for various reasons. And talking to you and understanding all of those aspects is critical for us to make improvement to all the ecosystem around events. So I just want to now mention what is the opportunity here, and we did a pilot recently to actually prove that it could be useful. So here what we see on the left is a set of segments that were mapped into Mexico City, but there were no actual MTEs mapped to it. So those segments were not connected together, okay? Just we had a lot of the closures ready there on the map, but they were not connected together into an MTE. So it means we were missing all the opportunity of sending those useful pushes, because pushes will be sent only if there is an MTE in the system. And we know there is a big pain in mapping those segments one by one today, because this is the issue that if we want to create an MTE, you have to one by one in a WME to assign them to an MTE. So we are aware about the fact that we need to have a feature that allows to do bulk association from segments to an MTE. And we are very aware about that, and we really wanted to make it happen. And in the meantime, what we actually did as a pilot is that we use what we call a clustering algorithm. And just to give you an intuition of how it works, So basically, it will take all kinds of specificities of the segments and try to cluster them together. And in our case, the specificities will be the geolocalization or the geographic location of the segments and the time at which they were defined to cluster them up together. And for this example, the algorithm can suggest that there is an MTE around here, right? There is an MTE because all those segments are nearby, one to the other, and also they are defined at the exact same time or similar hours. So we can understand and infer that there is something happening here, that there is likely an MTE there to be created. So what we did is that using this algorithm, we created a list of candidates. We did a pilot with Brazil, France, UK, to provide for each of those countries a list of candidates of clusters and have the editor review them and say whether or not it should be an MTE or not. And the results was really, really interesting. In Brazil, we got like 95% of those were actually MTEs that we can add to the system. It means that if we were to add those, suddenly we could increase massively the number of push that we can send to our users, right? Because suddenly there is an MTE in the system. Same for France, it was 76%. And in UK, I think we need to revisit it because we had on our side some differences, and it is interesting actually to observe the differences between geo, that the clustering was suggesting something that is different, and somehow it worked less good. But we know what to do to make it better, and if we want to redo this pilot, we will need to revisit a bit on the UK data. But it's really interesting to see the differences per country, and this is again a proof why we need your help, your hyperlocal knowledge for each of those type of features that we want to improve. So it's important to know that there is a Waze-wide task force around events altogether to improve and to expand all what we can do with events without closures, event without closures on polygons and everything. And we will definitely a lot of your help and your input to make this happen in the best way as possible. Now, the last part of the presentation. How much time do we have, Brett?
So we've got a good 40 minutes left, so no need to rush.
Okay, so that's good because it's a bit longer, but it's interesting. So let's see what we have here. We are talking about closure auto-detection. So we'll start, as usual, with an example, interestingly, again, sent by Roy Sasson, once again, about a closure that was happening in the real life and was not planned. It was not planned in advance. It was a demonstration. We had a lot of those recently around here, and Waze was not aware about this closure, which makes sense. It was not planned. We couldn't plan it in advance. So when something like that is happening, it's important to understand what is happening from the user perspective. So let's see it in action. First, when you have Waze asking you to go through this path, but it's closed, you have no choice but to continue straight, right? You can't go there on the left. You have to continue straight. So it starts already to be a bit annoying, right? You have no choice. You need to continue straight. Okay, Waze could have been know about this, and users are a bit frustrated about it. But okay, now I have a question. Maybe it will be harder to do it by chat, but I will ask it anyway. What do you think will happen when we continue straight because we have no choice? What would you say will happen, Brett?
I would like to say that Waze will pick it up after enough users abandon the suggested route to say that, oh, that route is closed, or the segments are closed.
So you are going one step further.
Okay.
But it's good. It's good.
I just have a lot of faith in Waze.
It's really good. But from the user perspective, what do you think will be the route that the user will see when he continues straight? One will expect to, I don't know, to have another route and get somewhere. But the thing is that Waze, because do we have some answers?
I'm not seeing anything in chat yet, but let's give it a few more seconds.
Okay, let's give it a few more seconds because it's actually interesting what is happening when we try to continue straight. Okay, I'll give the answer because it's not that obvious. I'm sure a lot of people have it in mind, but it's not that easy to write it. The thing is that what will happen is that Waze will try to get you back there. Why? Because Waze thinks it's still open. It still doesn't know it's open. So you are kind of entering like an infinite loop. You have no way to
Here we go.
Reroute. We do have some.
So Gonzalo says reroute, and if that happens to other Wazers too, then the other route would be suggested to others. Jeff said recalculate. Oh, here we get some more.
Okay.
From Peter, we recalculate whilst confused on where to go.
Okay, so those are good questions. So good answers. So basically, what we see here is that you are kind of entering a loop, and here you're kind of getting even more frustrated, right? You have no way to get routed. Like this is crazy, because when you think about it, like it's like we are losing our very core basic functionality. We can't do routing. You have to guess what to do. So you have to again not listen to Waze. It's kind of a double punishment like this. Like you have first to not listen to Waze, and then again you again don't have to not listen to Waze one more time. So at this point, we thought it was important to try fixing it. So first, before we go to the solution, let's see how it looks like from the data perspective. Okay, so here we have another example of an unplanned closure. Okay, and what we see on the graph is the traffic per minute on that segment during the whole day. So it's kind of pretty obvious that from 6:30 p.m. we had a closure. There were no traffic anymore at all. It's pretty obvious that it was a closure. So what was happening? So it was before we did any changes, right, to our model or anything. So it was last year. What would have happened in that day? And this is actually what happened that day. We got a lot of reports from drivers saying, hey, there is a closure here, which is good, right? Our drivers are very engaged, and we need that. So the system, when it sees like reports from drivers, is creating a closure typically after 2 reports, because we don't create a closure live after 1 report, because we want to have some confidence, right, about it. So there are all kind of details around it, but you can think about it like typically it requires 2 reports to create a closure. So this is what happened that day. What you see in green are actually live closures in Waze, okay? And what happened is that after some time, we just remove those closures, because we don't know if it's still reopened maybe on the road. So we don't want to take a risk, so we just remove those back in time, it was after half an hour. And what happened at that time is that it was not closed. The closure was still live in the real life. So drivers were reporting again another 2 times. It took another 2 times for reopening again a live closure. And things like that happened 3 times in that case. So if we think about it, what happened here? First, we didn't open in time. It took a lot of time before we were actually able to detect there was a closure, to understand there was a closure. Then we closed it too soon, and not only once, but 3 times. The only good thing that happened is that our users were reporting a lot about this closure. But when you think again about it, in all those cases where you see that Waze was not aware about the closure and there was a closure in the real life, all our users were experiencing a lot of those route deviations, those exact experience that we discussed before, like the double punishment of getting, rerouted and getting into a loop. So those are really trust-breaking moments. And it's not for nothing that users, when they are asked about what is the most important information they expect Waze to know in real time, closure came up as the first place. Because, when you get into those and stuck, it's really a very, very painful experience. Like, it's a trust-breaking moment for Waze. So this is why we wanted to invest a lot into those. And we'll describe in high level what is our approach to solve this kind of problem, like we did for the ETA prediction, or for many, many other problem we have in Waze. We took a very data science-oriented approach. And what we see here is, again, another segment. In blue, you have the segment traffic on that day, on a specific day. And in red, you have the same traffic, but on the week before, the same day, on the week before. Okay, so what we want to be able to do is to explain the probability, like to come up with a likelihood of is there a closure right now, given all the information we have in hand. So for instance, here it's obvious that there is no closure. The likelihood is 0. Why? We have a lot of traffic right now. It was a lot of traffic past week. Obviously, there is no closure. We can come up with a confident prediction of zero chance that there is a closure. Here as well, we have a very few traffic, but we know it's the night, right? And past week, it was the same thing. So it's not like it's we don't have traffic, so there is a closure. We can also confidently say that the likelihood is very low for a closure, right? But here it's interesting because we see a dip, like a very strong decrease in traffic, and we can start to understand that something is happening here, because last week it was not like that, right? It's not the typical traffic at that time of day. So here the model can try to understand, okay, it starts to be very likely that there is a closure. And here at all, like we see zero traffic. Usually it's a lot of traffic, so we can be very confident about the fact that there is a closure. And here again, when the traffic is resuming, then we can understand that we can release the closure, and actually drivers are getting through that segment, so we can just remove that closure. If we're able to get this kind of capability, then we can do what we call a great closure lifecycle management and understand that there is a closure exactly at this time. Okay, so
before we move on, maybe let's. I saw Peter wrote here in the chat something interesting.
Sure.
Using additional data points is a great idea. Perhaps this can be used in conjunction with single road closure reports for that additional confidence.
Thanks for the question. That's actually a great comment, because this is what we plan to do in the future. Like we have, like I was about to explain, we are currently focusing on high traffic segments, and I will answer your question in a second. But the signals that we are using are just the last 30 minutes of crossings and route deviations. But we can use much more than that. We can use, as you said, the reports that we saw on the road closure, and to increase the confidence. At the end, we just need to come up with a probability, right? So the more signal we have, the more smart we can be about this likelihood of having a closure. And single road closures reports are also another additional signal that we can use in the future. But right now, for the first phase, we focused only on the high traffic segments and those two pieces of signals that are the last 30 minutes of crossings and route deviations. And we use the machine learning model that is based on trees. No worries, it's CO2. It's like CO2 friendly. No trees were burned in the process. It's just the name of a model that is common in machine learning. And in the future, we will improve on all those different steps. Like we'll target lower traffic segments. We will use more signals, like was suggested by Peter and others. And the model also will get smarter. So the good news is that it is live for a couple of months already in all environments. And just to illustrate how it works, we will see it in action on an example that happened a few weeks ago. This is when US President Joe Biden visited in Paris for the D-Day. And there was a lot of closures that were unplanned. Unplanned, why? Because for security reasons, they are not able to say in advance where there will be closures. So what happened on that day, on that specific segment that we see in the picture? Let's see it in the data. What we see on the top are the car crossings, the same information we saw before, like per 5 minutes, how many cars are crossing. On the bottom, we see the route deviations, those experiences that we explained in the beginning. So you see that the traffic on the night is steady, and then we are increasing slowly in the morning hours. And then suddenly, there is a huge drop in traffic. And at the exact same time, there is a huge increase of route deviations. It means that something is happening, and the model is able to catch that and says, okay, I'm auto-detecting that now there is a closure on that segment. And you can see in orange, it says that there is now a live closure in Waze. It was auto-detected. And the consequence of that is that the route deviation are now dropping to 0. We are not sending user there anymore. So we are preventing all those super frustrating experience that we mentioned at the beginning. Now, after an hour, we have to take a chance. We are not sure if the road is still closed, so we just remove it. But what is happening is that immediately when we remove it, we see this huge peak of route deviation starting again. What does it say? It says that we don't see traffic anymore, but we see that the route deviation are again spiking when we remove the closure. It means that it's still there. We need to reopen it. So what we do is what we call auto-extension. We're extending the closure again. And again, the route deviation are dropping once again. And then after some time, the traffic is resuming naturally, and we can know that the closure is not live anymore in the real world, and we can just delete it, and then the traffic is resuming as expected. So this is what is happening when we actually using auto-detection live in the segment. So the question is how much it happens. So okay, I just want to give you an intuition on data. Brett, can we switch to another screen?
You got it.
Great. Thanks. So what we see here is the traffic on that day, the specific D-Day. So what we see in yellow are those closures that were auto-detected. And in blue is the closure that were planned, so added by you. So on that specific day, because we had no clue about what will happen in advance, a lot of unplanned closure, you can see a lot of yellow, right? Because a lot of auto-detection were triggered that day. And if you look at another day, for instance, the 6th of May, when we have a lot of ceremonials from the World War II victory and all these ceremonies that are happening, we can see here on the Champs-Élysées, Place de l'Étoile, for those that are familiar, a lot of blue, which is planned closure that were planned in advance. And if we look at the actual a full month of closure on Paris, and we play it like time lapse, you can see you have a lot of different days, a lot of blue, a lot of yellow all around during the month. And what is interesting here is to mention that your work is critical. Like your effort and help are critical in the sense that auto detection are not here to replace the planned ones. Why? Because the planned ones are providing a much better experience because we can send those pushes in advance, right? The auto detection are only there for all those unplanned closures that we couldn't have detected before that is actually happening.
I want to stop. There's a follow-up from Peter before we have more speculation
Yes.
in the chat. Out of curiosity in the testing, how quickly did this detection occur after deviations began to increase? And this is cool work.
Thanks a lot for the comment, Peter. And again, a great question. So the typical number of time, like the typical time that is needed to detect those is 5 minutes, because we usually those drop and spike of route deviation on high traffic segments are very, very sharp. And this is specifically because we are focusing on high traffic segments. For medium ones, maybe it will take longer, and those are the next phases that we will tackle.
This kind of fits in with the next question here, like how will this work in more rural areas where you're not getting that many Waze users for that sort of traffic?
Yeah, so for those, this is, we could actually spend an hour talking about the machine learning consideration that there is behind the scene and all the signals we plan to use. But for the next phase, we are targeting like medium level traffic. And we believe we can tackle those as well. And for those where there is not at all any information and no traffic, obviously for those we won't be able to detect anything, except for potentially what we call route deviation rate. Even if we have, I don't know, 10 users sent there and 10 out of 10 are deviating, then there is a strong hit. Even if it's few data points, we can understand that something is happening. So this is not for the first phase, but the quick answer is that for very, very rural zones without any traffic, we'll still need to rely on your help to not detect, but to map as much as possible the closure that we have there, and the users there will help as well. But overall, like on high traffic segments, we are capturing a huge chunk of the traffic.
Before we dive back in, just one more from Jeff. Can the community have access to this kind of screen and data? What exactly are we looking at here? Because this is something they've never seen before.
Okay, so what we are looking here is just basically a visualization. So each point represents a segment. And in blue, it's the planned closure that you are adding all the time. And so the tool that we are using, it's an open source tool that is called the Kepler, and all the data is kept local. I'm not sure we can actually share it. I need to ask offline. I think it's a legal and privacy question, but we can I guess at least see them here. To have them live and play with it, I think we need to ask offline. But that's a good question. But basically, it's a visualization of what is happening on a time lapse of 1 month. And one important point is that in WME, you can actually see when those closures are live, the auto detection closure. If you go on the edit option there, you can see the creator name, and the creator name for those will be Waze closures. It means, I think Khezi shared a lot of details about this. You can find them, I think, from the community, how it looks like. the WME. But if you have more questions, we can answer them offline. So back to our slides, we just have just few slides left. If we look at basically the same image but in other locations, so this is Paris for a full month. This is Sao Paulo, also a lot of yellow here and there. Tel Aviv, a lot of unplanned closures lately. For those living here, you know what we're talking about. And Mexico City, and Kuala Lumpur in Malaysia, and so on. So the system is actually impacting in Malaysia. It's actually a lot of the closure. So I think that's pretty much it overall. Here again, your feedback is critical, and I think you already sent us a lot of information about where closure seems to be live while they are not live in the real life, and the opposite side when we think there is a closure and it's already released. So you sent us already a great set of feedback, and we are looking at each of those because each of those are very precious to us to learn about, more how to improve our algorithm as usual. And I think it's important also to remember that at the beginning, when there is the spike of our deviation, there will be drivers that will kind of get this pain, the route deviation at the beginning to contribute basically to help us understand there is a closure. So there will always be a bunch of drivers experiencing those, but much, much, much less than before, because now we are overall, thanks to those algorithm and data, able to manage much, much better the lifecycle management. And again, I just want to mention and finish with that here, the auto detection are not here to replace your great help about mapping all those closures. Those are critical to get in advance as much as we can, because as we saw, this is what creates the best user experience, to send ahead of time those pushes and everything. And the auto detection are there only when we have no other choices than, something is happening in demonstration and everything. So I'm done with the presentation. And
I've got one more quick before we jump to the official Q&A from Jose. On can you distinguish between closures entered by editors and partners, and it'd be a good way to evaluate the closures entered? So right now we actually can. In the WME, you'll see closures from partners coming in from Waze feed, but one of the things that we're working on that we hope to have out before the end of the year is to give that attribution so you can actually see which partner is going to be submitting the closure in WME itself. And then, as you mentioned before, the closures coming in under the username Waze closure are from the auto detection.
Exactly. So that's a suggestion, right?
Mm-hmm.
Okay, makes sense. And great one.
Great. So if we're done here, I think that's it, right? So let's move us over for the rest of the time. We've got about 18 minutes left for Q&A. Denny, do we get some questions in? Yep. All right, awesome. So our first question from an anonymous viewer: does splitting or moving a road reset the data, like for example, traffic of the segment? So they're asking if they split the segment, if there's a new segment ID, if they move the segment in the WME, does that then affect the data that we're receiving on traffic for that segment?
So if we are talking specifically about the auto detection, then because the auto detection is related to the past half an hour right now, we are not really affected by moving a segment up to half an hour. So now we are just, focusing on this time window. And if we are talking specifically also about high traffic segments, it is less likely that those will be reset or split or moving, I guess.
So basically, the only way that this scenario could happen is if they caught it like right at the tile build.
Okay.
And they're like navigating, as the tile build is rolling. But that's such a minute possibility that I don't think it's a real concern.
Yeah, I see. But it's actually a great point when we will move to signals that are exploring like the past week's data. So in that case, we need to be aware that if there was a change about the segment, we need to be aware that the baseline of the past weeks might not be relevant anymore. So this is an important feedback, and we'll take that into account.
But then, for example, in this question for splitting, you're still going, let's say you have segments A and B, and then it's split then into A, C, and B for the new segment to C. Wouldn't you still be able to detect from A to B, regardless of if there's a new one in the middle there?
Yes, you will be able, because the crossings are shared for all those if they are consecutive ones. Then if you have a straight line, and people are not necessarily going out of the different turns, then you'll get still enough information potentially to detect what is happening. Because sometimes when there is a closure somewhere, because the segments are consecutive, enough that you close one of them, that the routing will be impacted for all the routes that were supposed to go through those segments that are consecutive. So we'll get still, I think, enough data to still be able to detect things.
Got it. Next up, from Anders. Passenger car with a trailer that have a limited top speed, in this case 80 kilometers per hour, the ETA that is calculated will be less accurate and in the end wrong for a longer route, including highways, given the driver and the destination receiving wrong information. Set the max speed in app to solve this. So first of all, I'm going to say a hard no, because Waze is not made for vehicles that are oversized or have more than 2 axes or too large of heights, or trucks. So we're not designed to support that to begin with, because it's not a passenger vehicle. At that point, it might be a passenger vehicle, but once they hitch on the trailer, they're no longer in that category. But I'll let you give your opinion on that. That was just more of the putting the Fej hat on and giving the, no, we're not doing this because it's not Waze's purpose.
I think you answered it. Although we do have good things coming up for ETA for motorcycles to get them more accurate.
That's very exciting.
So yes, but on this, I guess you already gave the best answer.
All right, cool. I get to answer one once in a while. Another anonymous question. For MTE, a big thing is missing: taking the MTE closure into account when calculating an itinerary that will cross an MTE area when closures are active, even if the trip starts before the closure actually begins. In certain regions, it can avoid hours of detours.
Yeah, so that's a great question. So I guess if I understood it correctly, is that, okay, let's say there is a closure that we know about that is about to open, let's say in 20 minutes. Mm-hmm. And we are going out right now from home, and in 20 minutes we'll be there. And today it's not taken into account. So actually there is work that is done around this. I don't want to commit on any timeline on everything, but you know that we want to take that into account. It's definitely in our radar. And again, I don't want to commit on any dates for that, but this is something we definitely consider and that we will take into account. So we can say offline maybe more if there is any, I don't know, plan, timeline and everything, but I don't want to commit about it here. But
I mean, this is a question that comes up at every mega meetup I've been at, actually.
Okay.
Where that it's one of the things that Waze does need to improve, that we're not taking into account these future closures if you have a long drive ahead. So it's wonderful to hear that it's something that we're working on.
So maybe what we can say is that for the Tour de France, that is up the line, we want to take actually those into account, and maybe a pilot where we want to test those.
So we are actually doing a lot of work right now to revamp the entire MTE experience. I know many of you may have received it for the different Pride parades that we're doing around the world right now. It turns into a really amazing test for us to be able to test the same event in multiple different metros, all in different countries around the world. Mm-hmm. One of the other things that we're doing for this new MTE experience is also, as you mentioned, Tour de France, and then also the Paris Olympics. So we have a lot of focus this summer, especially on making sure that this new experience is rolled out, and it's going to be very beneficial for users to see the whole big picture all on one screen. What's up next, Danit? So from Yoav, why does Waze rely only on auto detection closures? Why not ask the users, is there a closure after route deviation, or is the closure still there?
That's a great question. Again, we see that it's a bunch of smartphones around.
This is the biggest expert community we could possibly throw you in front of. So I'm throwing you to the wolves right now. And this also might be something that I think is more relevant for Surfacing Squad and not so much for data, but if you want to take a crack at it, feel free.
Sure. So again, it's a great comment. I think like here the challenge is that when you want to say something about a segment that is not on your route, when you had to deviate and you need to ask the user, is there a closure there? So first, I think we are starting to a new experiment about an easier way to detect, not to detect, but to let the user report about a closure, which is today a very complex and cumbersome experience where you have to click a lot of times. And so we want to have a very, very much simpler experience, and we are going to have something like that allows it to do it in a much simpler way. But here there is a comment about, okay, there is a closure live. Is it still there? It's also something that we want to consider in the future. And it's just that it is a bit challenging in the sense that it's not on your route. You need to ask a question on a segment that the user might not necessarily see. Maybe it's behind a highway. It has some components that are not that trivial on the UX and UI perspective. So this is definitely something we want to consider. This is just, it might take a bit time before we nail the actual experience and the UX on this.
I do also, not this one, I do want to shout out as well what Jeff mentioned, to really congratulate our French map editors for their amazing contributions this summer with Tour de France and the Olympics. They have so much on their plate, and they're doing an amazing job making sure that we have all the data that we need to make all these MTEs successful. All right, next up, from Alexander, we sometimes have situations where segment speed or cross time is totally wrong, far too long to be reasonable at any time of the day, which can cause extreme errors in routing. Is there a plausibility check for such issues? For example, a segment says 240 seconds even at 2 a.m., whereas it should be about 10 seconds.
Okay, that's interesting. I think, like, again, when we mentioned before that each of your feedback and examples are precious, this is definitely something we can look into. So if you can send us the specific example, we will definitely look into it. And each time we learn something new, and it helps actually us to improve our models. So I know that there is a kind of mechanism that prevents to send, like, to return completely, like, huge cross times for segments, like a safeguard mechanism, but sometimes it can be off. The example of junction boxes was one of them. And each time we get those, we deep dive into the data, and we usually learn something. So if you can, Alex, send us your example, we'll be gladly looking into it.
Also, to just correct my faux pas, also, of course, I want to congratulate and thank the Italian community and the Netherlands community and the Belgian community for all of their hard contributions on Tour de France, because you all are definitely contributing as well. Okay, next up.
Tour de France is a misleading name because, you know,
it is. Right.
Yeah.
It's actually starting in Italy this year.
Yeah.
From Lori, at the North American Mega Meetup, I was told that MTEs of the construction type do not get pushed. Is this the case? If so, is there any value to creating an MTE for road construction projects? I think this is not the right presentation for this one, because this is more on the surfacing squad side, not on the data side, unless you have maybe some insights into what gets pushed and what doesn't when it comes to the type of MTEs that they're coding.
As far as I know, like MTEs that for which we can send a push has to go through a process where we say, okay, with this one we can send a push, but I'm not really aware about the types. So I will leave it for the question.
It also might be a lot of the construction closures that we get tend to be only for one lane or with a relevant detour. It might not have an impact, or it might be at off hours. So maybe the closures team isn't publishing like those types for a specific reason, but it's definitely something we could take another look at. So Laura, you can feel free to send me in an example and we'll send that over to the team.
What I can think about though is that if the roadworks is something recurring, like happening every day or every day for a long period of time, we don't want to send pushes every day over and over again. So maybe we need something to be handled. I'm not sure, but this is something we can check offline. Actually, it's a good remark.
So next up, another anonymous question. Would it be possible to display the average speed of a segment in WME to double check the speed limit, for example? So that's interesting. So like to display on the segment in WME, the average speed that drivers are actually driving on the segment.
Interesting one.
Yeah, that's kind of an interesting feature request, but let's move on from that because it's not super relevant to what we're talking about today. From George, would it be possible to notify editors when segments in a given area are closed by this mechanism? So like to give like a heads up to drivers and a warning when the system auto detects closures to like give users advanced notice on that.
So the question is about for editors or for actual drivers, like when we auto detect?
Possible to notify editors. So I guess how would that work to open up a UR in the WME when we've created the auto detection on the closure?
So basically, I guess like when there is an auto detection, we can surface it in some way to WME. It's a feature request here as well. It's an interesting one. So I guess the idea is for the editors to be aware of those, to I don't know, in some sense validate them, or be more aware about is happening, something like that. I think it's an interesting suggestion. We can think about these kind of things. Like all of the reflection of closures auto detection to WME is a very large topic, and I think we can in the future have a lot of different discussion with you on it and see what will be the most useful information that you will get.
So I think this Will is saying like a bit like a GPS overlay where you can see the last 30 to 60 minutes and see the exact reroute. That's interesting.
Okay. I think we can have like sometimes a separate session about what will be useful in WME to be reflected around auto detection, something like that.
Make a really interesting feature discovery call for sure.
Okay.
Cool. Moving right along from Jean-Francois. Concerning the spatial info, the basic duration based on the segment type, street, whatever, I'm not going to read all of those. Is it possible to adapt it per country, like the segment default speed used in case of no segment data? The reality in Western Europe or in the US is different than the one in Asia or Africa, for example.
Interesting. So I know the actual team from building like that is building the SmartSum deep learning model are always looking at per country data. It might be that I don't have the exact details, so maybe we'll take it offline, but about where we stand with having a model per country and to understand the differences, because we definitely have differences per country, that's for sure. And this is something we're always looking at. I don't have the latest state of things on that, but we can answer offline if needed.
Cool. Next up from Guillaume, can the auto detection of closures mechanism be used to fine tune the start and or ending of scheduled NTEs, like starting early or ending early or later than the scheduled time? Well, that's an interesting one too.
Yeah, that's a very interesting one. I agree. So first, you're probably aware of this mechanism that before we actually start any closure that was planned in advance, we first check that there is no traffic anymore. There is a kind of delay period where we check if there is no traffic. Otherwise, we wait a bit before to actually start the closure. So this mechanism is existing already. Now, for having the fine-tuning of start and end of the scheduling closures in general, may that be empty or not, we can potentially at the end use like the information from the MTEs and the planned closure with the likelihood estimated by the model to take more informed decisions. But we are not there yet. This is something we didn't yet consider, but that's a great suggestion that we can definitely take into account in the future.
Excellent. Next up from Peter, any data on how many auto closures have been false positives? I assume the rate could be low, but possible.
Great question as well. So, like I mentioned in the presentation earlier, we first focused on only those very, very, very high traffic segments in such a way that we are very, very confident. If you look at the actual tree model, you will see that it's a bunch of at the end of conditions that makes it almost impossible for it to be completely wrong, because we are asking for a very sharp drop of traffic, a very huge increase of route deviations, and also no traffic or almost no traffic going on at all. So the rate of false positive is close to zero right now, up to the fact that sometimes we might leave the closure open for a bit too long, because maybe it's still open right now in the real life. So for that, we rely on what we call the suspension mechanism. When there is traffic observed, we immediately remove the closure, or we have this safeguard of removing the closure after some time. This is what we saw on the slides, in such a way that we won't have a risk to keep a closure auto-detected for too long. So we have all those mechanisms, and we are actually looking in depth at a lot of examples, including yours. And each time, like when we look at something that is looking like not in line, it's more because like the traffic is resuming right now, or just the closure just started or something like that. So the false positives are close to zero right now. It will be more challenging in the future when we will tackle medium traffic segments. And this is where we will have to invest in more machine learning machinery to make sure we keep the false positive rate close to zero.
Coming back. Makes sense. Thanks. It's considering edge cases for sure.
Thank you.
And I think this is going to be our last question. We only have 1 minute left from Victor. we have an underground freeway without beacons. It always says that there is traffic there with low speeds day or night. I'm sure that affects ETA and then routing decisions. How can we manage that?
Oh, that's a great question. That one, I'm not sure I have the answer, and I prefer to delegate it offline to the relevant person on this specific one. I don't want to say something that is not in line.
Absolutely. All right. Well, should we take one more, Danny? We still have some time. Let's do it. So from Jay, with auto detection, are trust levels still taken into account, i.e. closures from editors versus non-editors? So, and that's another question too on reporters that I saw in the chat as well. Like how is the trust level being taken into account here? I guess it doesn't really matter because it's not reporting, it's based on their routing.
Exactly. So, so when we were talking about trust levels, we mean about the drivers that are reporting. Yes, so this is still there, meaning that we take them into account the exact same way as we did before. It does not impact right now auto detection. The auto detection is really based solely on the traffic signals. In the future, when we will have some medium traffic segments and when the probability is a bit in the middle, then the trust level and the closures from UGC will come up as another signal to actually make the probability a bit more precise in the way we said before. Like we can combine the trust level and the UGC closures, like the one reported by drivers, together with the traffic signals to make up a better probability altogether. That's the plan, to combine those together.
Excellent. Well, Philippe, this was super fascinating. Thank you so much for joining us, especially last minute. I really think the community obviously really enjoyed it. We had such a lively chat and a bunch of Q&A tonight that I know we didn't even get to all of it. So with that, thank you all again for joining us. If you have any other follow-ups, you can send that to your community manager and they'll make sure it gets to me and to Philippe. And then we'll answer you back on the forum once we have some answers for you on the things that we left out or weren't able to get to this evening. So thanks again. Thank you for joining us.
Thanks for having me.
And we'll see you all next month for another exciting edition of Office Hours. Bye, everybody.
Bye.